Graphing systems of inequalities. A system of inequalities just means two or more inequalities that are graphed on the same Cartesian coordinate system. This is an example of a system of inequalities. Both of these inequalities are linear, and I know that because they're not raised to any power other than 1. None of the variables are raised to any power other than 1. So I'm going to take each inequality separately and graph it. There are different methods that you can use to graph linear inequalities. You can create a t-table, you can find the intercepts. I'm going to graph it by getting it into slope-intercept form. Y equals mx plus b. So this first equation, I'm going to rewrite it first. X minus 3y is less than or equal to 6. And I want to isolate the y. And to do that, I'm going to subtract x from both sides. And that gives me a negative 3y is less than or equal to negative x plus 6. And then I need to divide every term by negative 3. Well, since I am dealing with an inequality, and I'm dividing both sides of the inequality by a negative number, then I need to flip the inequality symbol or reverse the inequality symbol. So instead of less than or equal to, I'm going to reverse it to say greater than or equal to. Y is greater than or equal to, that would become a positive 1/3 x minus 2. And now let me rearrange the other inequality and get it into slope-intercept form. So this bottom inequality, I'm going to subtract 2x from both sides. And that gives me 3y is greater than or equal to negative 2x minus 6. And then I divide every term by 3. Well, this time I'm dividing by a positive number, so I do not need to flip the inequality symbol. Alright, so I have y is greater than or equal to negative 2/3 x minus 2. Alright, in this inequality, if I pull out the slope and the y-intercept, my slope is in negative 2/3 and my y-intercept is negative 2. In my other inequality, my slope is a positive 1/3 and my y-intercept is negative 2. Alright, for my blue inequality, I am going to graph this line, and by doing that, in order to do that, I'm going to plot my y-intercept first, which is negative 2, and then my slope is in negative 2/3. So remember, when my slope is negative, I need to put that negative sign with either the numerator or the denominator, but not both. So I either go down 2 and to the right 3, or up 2 and to the left 3. And I'll look at my inequality symbol to determine whether the line should be solid or dashed. If it has the equal to underneath it, that line underneath it, that tells me that my line is going to be a solid line. So I'm going to connect my dots by using a solid line. And if my equation is in slope-intercept form, greater than means I shade above the line, less than means I shade below the line. Well, when I'm graphing a system of inequalities, my solution is actually going to be the shaded part that overlaps in the inequalities. So first of all, I just want to lightly shade so I can know which side of the line the inequality is shaded on. Well, this says y is greater than or equal to negative 2/3 x minus 2. Greater than or equal to means above the line. So this direction, again, lightly. I just want to know what side of the line is shaded. Now if I want to graph the other line, my slope is 1/3 and my y-intercept is -2. So I'm going to start at -2, which is the same y-intercept for the other line. But I'm going to rise 1 and run 3. Rise 1 and run 3. And I connect my dots. Again, this is greater than or equal to, so it's going to be a solid line. And when my equation is in slope-intercept form, that's when I look at it. So right here, when I look at that inequality, it says greater than. So it's everything above that line, which would be all of the stuff in this direction. So like I said, the solution to the system of inequalities is the part of the graph that overlaps. Well, the part that overlaps is this part here. So this is the actual solution to the system. This is another system of inequalities, but these are not both linear. My bottom equation is a line because the highest power is 1. But my top equation is not a line. So remember, if both my x and my y are squared, then it's a circle. But if only my x is squared, it's going to be a parabola. So we have to ask ourselves those questions to determine how to graph this parabola. When we're graphing a parabola, we first want to know what direction it opens. Remember, whatever is in front of that x squared, if it's positive, it's going to open up. If it's negative, it's going to open down. So we know that this graph opens up. Then we want to determine what our x-intercept is and what our y-intercept is. Well, to find out what my x-intercept is, I plug in 0 for y and solve for x. So if I plug in 0 into my inequality for y, that would give me 0. And I'm going to change it to an equation just to work it out to find my intercepts. So this would be 0 is equal to x squared minus 4. All right, the easiest way to solve this, well, we could either factor it or we could use the square root method. If I use the square root method, I want to get whatever is being squared by itself. And that gives me 4 is equal to x squared. And to solve this, I'm going to take the square root. And when we take the square root of a number, we put plus or minus in front. So I get x is equal to plus or minus 2. So my two x-intercepts are positive and -2. So I have 2, 0, and -2, 0 for my x-intercepts. For my y-intercept, I'm going to plug in 0 for x. And again, I'm changing it to an equation just to make it easier to solve. So I get y is equal to, I plug in 0 for x, 0 squared minus 4, which is just y equals -4. All right, my center, or my vertex of my parabola, if you'll remember, the standard form of a quadratic equation is y is equal to a times x minus h squared plus k. And so my vertex is my h and my k. So in this case, my vertex is 0, -4. All right, so let me plot my vertex, and then that's not my vertex. My vertex is at 0, -4. So I'm going to go down 1, 2, 3, 4. And then that's the same as my y-intercept. My y-intercept is at -4. And then I have two x-intercepts, one at 2, 0, and one at -2, 0. Well, if you'll remember, I need 5 points to make a good parabola. So I just need to choose another point to plug in. Well, I would choose a point between my vertex and one of my x-intercepts. So I could either choose to plug in 1 for my x or -1 for my x. I'm going to choose to plug in 1. So if I plug in 1 into my inequality for x, that gives me y, again I'm changing it to an equation, y is equal to 1 squared minus 4. 1 squared is 1, and 1 minus 4 is -3. So I plugged in 1 for x and I got out -3 for y. Alright, so 1, -3 is another point on my parabola. And remember, we have that imaginary axis of symmetry. So if I go one space to the right and I have that point at 1, -3, I know I'll have another point at -1, -3 because it's symmetric. Alright, when I look at my inequality symbol in my original equation, it's greater than or equal to, so that means I have a solid line. Okay, and now I need to determine if I shade inside the parabola or outside the parabola. Well, if I choose a test point to plug in and I shade the true portion of the graph, if I chose 0, 0 as my test point, which is the origin, if I plug that into the original inequality, so I plug that in at 0 for y and 0 for x. If I simplify that, I get 0 is greater than or equal to -4. That's true. So that means where that point is, 0, 0, where that point is, that's the true section of the graph. So that means everything inside the parabola is also true. Again, I'm graphing a system, so that means that I am looking for the part that overlaps. So I'm just going to lightly shade this to remind myself where the true part of the graph is, or where the shaded part of the graph is. Now I need to go back and graph the second part of this system of inequalities, which is a line. So in this system of inequalities, the line is x plus y is less than or equal to 2. I'm going to get this into slope-intercept form to graph it. And to get it in slope-intercept form, I need to get the y by itself. So I'm going to subtract x from both sides. And I get y is less than or equal to -x plus 2. Okay, that's in slope-intercept form. So my slope is whatever's in front of x. Y equals mx plus b. So my slope is a -1, which would be the same thing as a -1 over 1. And my y-intercept is 2. So my first point is going to go at 2 on my y-axis, and then I rise over run, so either down 1 into the right one, down 1 into the right one, or I could go up 1 into the left one, up 1 into the left one. Okay, so I need to determine if my line is solid or dashed. Since my inequality is less than or equal to, then that means that it's going to be a solid line. And I always look at, if it's linear, I look at the equation in slope-intercept form. And if it's in slope-intercept form, if it's less than, it's below the line, greater than, it's above the line. Okay, so this is less than, so it's the stuff that's below the line, which is this stuff down here. So the part that overlaps, or the solution to my system, is this part in here.